Hi everyone, this video is an exercise 13G question 10. So we have this curve and two regions, R1 and R2. So in part A, we want to find the area of R1. Okay, so before finding the area, we need to know what's this x coordinate here, which is one of the roots of this equation. So in fact, if you set x squared times x plus 4 equal to 0, you'll get 0, and the other solution is minus 4. So therefore here has x coordinate minus 4. Okay, now that we know that here has x coordinate minus 4, part A is very straightforward because the area of region R1 is just equal to the integral of the curve from minus 4 to 0. And that gives us the area of R1. So for part A, we have the x squared times x plus 4, but we need to expand that. So x squared times x is x cubed plus 4x squared dx. So again, I just expanded the bracket, which is the equation of y, and then that gives me x squared plus 4x cubed plus 4x squared. Okay, now the derivative is equal to, so x cubed integrates to 1 over 4x to the power of 4 plus 4 over 3 x cubed, and then we have 0 minus 4. So at this point, we just substitute 0 and then minus 4 substituted, and that gives us the value 64 over 3. So this is the area of region R1. Now part B is about finding the value of B. But also another important fact that is crucial to part B is that the area of R1 is equal to the area of R2. So we can immediately write down that the area of R2 is equal to 64 over 3. And this is going to be very important for finding the value of B. So all we need to do in part B is essentially setting up the integral that gives us the area of R2, and then set that integral equal to 64 over 3 because we are given the value of the area. So all we need to do is finding the upper limit of the integral. So, all right, it depends on how we set up the integral. So it's not necessarily the upper integral. So I'm going to show you in a few seconds. But that's the general idea. So we want to form an equation, and then solving the equation is going to give us the value of B. Okay, now let's look at R2. So in terms of finding the area of R2, one possible way is that saying that, okay, let's use the area under the curve. But the thing is, if we only rely on the area under the curve, that's not going to give us the entire area of R2 because the curve is from 0, and then it's basically when you have the line. So you have kind of this sort of red region. So if you only integrate the curve from 0 to 2, that's going to give you the area of the red region. So still, we need to find a way to find the area of this blue region. And that's in fact just simply finding the area of this triangle. So that's going to give us the area of the remaining part of R2. Yeah, because if we only rely on the curve, we are not going to get the entire area of R2. So with that said, the integral for the area of R2 is equal to is basically the area of the curve. By the way, it's between 0 and 2 because here has this end of the curve has x coordinate 2 of the curve, which has the equation x cubed plus 4x squared dx, and also plus the area of this triangle. So this triangle has height of 24, and then the base here obviously is 2, but here is b. So we don't know the base, but we know that base is equal to b minus 2. So the area of the triangle is equal to base, which is b minus 2, times height divided by 2. So this is essentially the area of the triangle once again, because the difference is b minus 2, so that's the value of b. And all of this is equal to the value 64/3. So let me rewrite this. Okay, so now that we have this equation, we just need to solve the integral as much as we can, and then finally solve the equation to get the value of b. So you already know that the value of the integral is equal to, I mean, when we integrate, we'll get x to the power of 4/4 plus 4/3x cubed. And then this time we have 2, 0 as the limits. And then here, so we just have 12 times b minus 2 is equal to 64/3. So now we just substitute the numbers 2. So we first substitute 2 into the bracket, and then minus 0 substituted, but obviously that's just equal to 0. So by substituting that, by substituting 2, we'll get 44/3, and so that's 44/3 is the value of the bracket after substituting the bounds. And then for this part, we just expand the bracket, so we'll get 12b minus 24 is equal to 64/3. Okay, at this point it's just a simple equation, so we just rearrange that. 12b is equal to 92/3, and then b is equal to 12 divided by that, which is equal to 23/9. So yeah, this is the value of b. So this was an interesting question because it wasn't about finding the integral, but finding the value of b.